Okay. Algebra is about two big ideas, and those two big ideas are operations and groups. You haven't maybe heard it expressed this way before, but for example, some operations we do in mathematics are addition, subtraction. Did somebody give me some other operations we use in math?
Multiplication.
Good.
Division. Exponents. That's not. Okay.
Exponents, good.
Parentheses. Please excuse my dear on salad.
Square roots, yeah.
Square roots.
Absolute values.
Absolute value. There's other things that we do. Maybe you guys have seen this before. Maybe you've seen in trigonometry sine of something. That would be another operation. Okay. Today we're teaching you guys a brand new operation that you're not familiar with. Okay? And it's an operation called composition. Composition is simply a small circle. It's a small circle. Now you're automatically going to want to try to reference this as, well, what is it like compared to multiplication? What is it like compared to addition? It's not like those at all. I'll share with you what composition is in a second, but we also have groups that we operate on. One group would be numbers. You're used to operating on numbers, right? We're also used to operating on algebraic expressions. For example, like x plus 2 times x minus 4. We're operating on an algebraic expression in that situation. What today's composition is, you don't use really numbers or algebraic expressions so much as you use functions. Functions f and g. Functions f and g. So composition is the operation, and the groups that we're going to operate on are functions. Here's how we define f of g of x. So this is the operation, this little circle thing here. And what this means is that you take x and you plug it in for g. And what you get out of that is g of x. Already talked about evaluating functions, but that notation should look familiar, right? Anybody want to guess what we do with g of x once we get that out?
Plug it back in.
We plug it in for f. And what you get out is f composed of g of x. Now, yep, a lot of people say fog. You can write it slightly differently, and that might make more sense to you. F of g of x. Those two are synonymous. They mean exactly the same thing. Okay? Once you see one, you're good with the other. We're okay with that? All right. So let's move to letter A. It says f of g of 0. Okay? This means the same thing as f composed of g of 0. Okay? Those mean the same thing. Now, you don't have to write it differently. I'm just showing you so that you can make reference later on. But all this means is I take 0 and I plug it in for g. So I'm going to go to my g function here, and I'm going to plug in 0. What is 0 squared plus 2 times 0? 0. So g of 0 becomes 0. That thing became 0. So I now determine f of 0. So I will take 0 and plug it in here. 2 times 0 minus 3? Negative 3. We'll try again. Now, we're going to do g of f of 0. Where are we going to plug 0 in first? Are we going to plug it in for g, or are we going to plug it in for f? Yeah, you plug in 0 in for f. And what do you get when you plug 0 in for f?
G of 3, or negative 3.
You get 2 times 0 is 0, minus 3 is negative 3. So this becomes g of negative 3. Now, where do I plug in the negative 3? I plug it in for g, and I have negative 3 squared plus 2 times negative 3. Negative 3 squared? 9. Plus 6 or minus 6? Which is 3.
So is the final answer be 3?
Yep.
It wouldn't be like,
It wouldn't be the 0? Cody here?
Yeah.
Yeah. They didn't ask permission to remove him from class.
They did. Kobe, I think you need to stay here.
You did not ask permission to remove him from class. I have a special form that you have to fill out if you still remove somebody from class. Looks like he's just gonna go anyway. Okay, now we do f of g of negative 1. Notice how it's written differently. This is the same thing as f of g of negative 1. I'm going to take negative 1 and I'm going to plug it in for g. What is negative 1 squared? 1. Is it going to be plus 2 or minus 2?
minus 2.
Minus 2. So negative 1 squared is 1, minus 2 is negative 1. So this becomes f of negative 1. Now I plug negative 1 for f. 2 times negative 1? Negative 2. Minus 3? Negative 5. I would like you to try letter D on your own. Try letter D on your own. See if you can come up with the same answer that I get. Okay? Try D on your own.
Get this thing done.
Right?
Sure.
Yeah.
What up, JJ?
Yeah.
No.
A lot.
Yeah.
No, F you do.
No, F first.
Michaela.
Oh, wow. Why are we so crabby today?
Never.
So you take negative 1 and plug it in for G.
Negative 4 minus 3.
You get negative.
And you take negative and plug in for F.
I understand. The moment I see it, negative.
So then it's, but then don't you, is it G negative 7 or F negative 7?
It's just like done.
I haven't gotten that far. Shut up.
I don't know what you're doing. So you're taking negative
It's not that hard.
2. So I don't know any other ways to explain it. You take negative and plug it in for F.
F
So
first.
2 times negative 2 is,
Oh, okay.
I got
did not
63.
Or you can take
What? Oh wait,
That
minus.
should be a minus 14.
so, so
I
F
got
of
35.
negative 2 is negative 7.
Is the answer 35?
Why did you
So
do
then you're gonna plug that in for G.
No, it'd be 35.
The
You're an
negative
idiot.
7 goes in for
It's
G.
35.
So,
You're an idiot. You don't care.
it's 35. Why'd you tell me 37? You said 37.
Oh my goodness. You didn't need to today.
Minus 14.
You just said do D.
35 is correct.
Why are there two F's though?
Try to ask me you.
Yeah, what the hell?
What?
Yep, it's your first one, so negative 7.
This is why.
Yeah, no she's not.
Yeah, so you
Totally.
go ahead. Yep.
Are you hungry?
You're so lucky I
Got
didn't
it.
meet
Perfect, that's it. You got it.
Wait, oh, I told you. I'm just useless.
You do, bud.
Barbara's sitting over there, and I'm thinking,
You're scary.
you know, for the amount of pink you're wearing today, you'd think you'd be nicer.
Okay, if you take negative 2 and plug it in for F, I have 2 times negative 2 is negative 4, and negative 4 minus 3 is negative 7. So you get g of negative 7. Now plug negative 7 in here. Negative 7 squared is 49. And is it going to be plus 14 or minus 14?
Minus.
And you should get 35.
I said that. That's why I got 35.
We're good with 35?
That's a weird looking three against. That's like a backwards C. That's better. This might be it.
All right. What's different about letter E?
There's two F's.
There's two F's. And so we are going to take 1 and plug it in for F.
One, plug it in for F.
And what do you get when you plug in 1 for F?
That's a negative 1.
You get negative 1.
Don't you just plug it in for
So then you take negative 1 and plug that back in for F again. And you get 2 times negative 1 is negative 2. Negative 2 minus 3,
Negative 5.
negative 5.
So the negative 5 would be your answer?
Yes.
So 1 plus 2.
Okay, we're going to skip a few here, and we're going to move to G and H. What's different about G and H?
They have
Yeah, they have letters instead of numbers. And that's okay, because we're really smart people and we can figure this out. F of x is 2x minus 3. G of x is x squared plus 2x. So in the first example, instead of plugging in a number, I plug in the entire function g. So I'm going to take, notice how g sits on the inside. I'm going to take all of this, and I'm going to place it right there.
I don't even know. Wait, explain that again, please.
Okay. See how g of x is sitting right there?
Yeah.
I'm going to plug that in for f.
I got it now. I got it now.
And so wherever I see an x, I just put an x squared plus 2x in its place. So this is going to become 2 times, and instead of x, I write x squared plus 2x minus 3. So I get 2x squared plus 4x minus 3. Factoring doesn't necessarily mean that it's more simplified. Factoring is just another way of writing it. If you could get something to cancel, then you could factor, but we're just going to leave that be. Notice in the next one, it's g of f. So what's different about that is I take this and I place it into both spots where I have an x. It has to go into both spots. And if you put it into both spots, you get 2x minus 3 quantity squared plus 2 times 2x minus 3. Now that's going to take a little bit of work to multiply that out, isn't it?
Indeed.
But fortunately, we're very intelligent, so we're not going to shy away from doing it. This is 2x minus 3 times 2x minus 3 plus 2 times 2x minus 3. So let's multiply out 2x minus 3 times 2x minus 3. What do you get? 4x squared minus what? So I get 4x squared, and then my next one would be minus 6x, then my next one would be minus 6x, and then I would have plus 9, plus 4x, minus 6. I'll combine my like terms together. I have a 4x squared. How many x's I'm going to have? I'm going to have a negative 6x, a negative 6x, and a positive 4x. Negative 8x. And then I have a positive 9 and a negative 6. Positive 3. That was a little bit challenging, right? Okay, flip it over. This is our last part. This is nice and easy.
Oh my goodness. Oh wait.
So as we continue to work through this, we're kind of in our last bit of the semester, and if people haven't kind of caught on to some of my motivation at this point, we've given you what we think is a pretty solid foundation so that you can enter college and really have a good shot at your college algebra class if you were to take it. Some of the things that we're talking about right now, for many of you, you haven't seen this before. And what I find is that when kids go on to college, when they encounter something that they haven't seen before, they're very quick to quit and run the other way. Had a student one time, she was taking Calc 2 in college, and she saw something early on that she didn't really recognize. She got a B+ on her first test, so she decided she would drop the class at that point. Is that really the toughness and the resiliency we want to see from our students?
No, ma'am.
Absolutely not. In fact, I had her mom in my classroom during conferences, even though she had graduated. Her mom was in my classroom crying, saying the best thing I could have done for her daughter was to challenge her a little bit more, because right now she got to college and she was absolutely just absolutely blown away by seeing new things. And I felt bad. I think the daughter probably thought that I probably tried to prepare her well, but needed to show a few things. So what I do in my classes often is I try to show a few things that you might encounter. And I know that for the calculus students, that pays off big time. I try to show a little bit of calculus 2. Like, well, why are you showing calculus 2? It's just calculus 1 you're teaching. Well, that way when they see it, they don't run away. When you see composition, is this really that challenging of stuff?
Maybe.
No, but it's new, isn't it? And so sometimes when people see it, they're like, I can't do it. I don't know how to do it. And right now, this is a graphical example. I know as people look at this right up top here, that may seem really, really, really scary to you. It's like, oh, shoot, what the heck are we doing? We're going to do the first 4, but it's not that bad. We're doing f of g of 1. G is the red function, and f is the blue function that I have up here, okay? So am I going to start by plugging 1 into g or by plugging 1 into f? I start by plugging 1 into g. You plug into the one that's closer to it, okay? So let's remember how that goes. We practiced this the other day. I plug in 1, and what is the output for g at 1?
-1.
Positive 3.
Wrong line.
Everybody see g has a height of positive 3?
Yeah.
So this becomes f of 3. We found that g of 1 is 3, so now we do f of 3. So instead of locating 1 now, I go over to 3. And what is the height of f at 3? It is -1.
Wait. But this one you go to F first.
Let's try the next example. I take -2 and I plug it in for f. If I take -2 and plug in for f, what is the height of f at -2? Positive 2.
Follow the line, guys. You got it.
Oh, no, it
Come on,
crossed up.
You got to flip it down.
Zero. Oh,
Spencer, this is sad.
It's also harder for us because it is black and white.
Yep, totally get it. A lot of people, when they get to this, they will take out their red pen or their blue pen, and they'll draw one of them a different color to help them out. So if you need to do that, then that's what you need to do. Now we move on to 2.
Yep, you're right.
If I plug 2 in for G, what is the height of 2? Height of G at 2?
2.
It is 2. So we'll give you some practice. Please do the next two, G of F of 1 and G of negative 2. Try those two, see if you can come up with the right answer.
Did you get that? How'd you get 2 right there? Meadow? Why? How'd you get 2 right there? I got 0 right there, but we got the same answer, so it doesn't really matter. You do you.
Stays at 2.
G at negative 2 stays at 2 is 0.
Okay, so you did 2. We have negative 2.
Oh, you have negative?
It's a negative 2. Take another 30 seconds.
I can do that.
I got 1 and I got 2.
Me too.
So we're on the same page?
Sure.
Okay, so if I may, and just end with this, was this new today?
Yes.
Was it super complicated? No. If you missed today, could you see how it could be complicated?
Yes.
And thus, I cannot tell you, I talk to people who work in colleges all the time, they will say the number one obstacle for students is attendance, that when they do not show up, they miss. You guys talk to some of your peers about college, I'm assuming? Raise your hand if you know